Now that we know the theorems that help us prove that triangles are congruent, we're going to circle back to the format that we had with similar triangles to prove that triangles are congruent using flowcharts. Our first example is fairly straightforward, where they've given us 3 side lengths and we can start matching short to short, medium to medium, long to long. I still like to color code to make sure that I'm matching up the correct side lengths from here to here, here to here, and here to here. Now, how we write these sides can be written different ways. Notationally, we want to be a little more accurate with how we write our statements. In this case, if this was a similar triangle, we'd set up our ratio to say BC over ED and see that scale factor would eventually be 1. Now, we can write that different ways, but it depends if we're going to use an equal sign or a congruent sign. An equal sign is when we know the actual side length. So I might say BC equals ED, which equals 4.5. Now, when we get to congruent triangles and flowcharts, a lot of times we don't know the side lengths. So we can always opt to this statement for using a congruent sign, but then we have to put these little segment lines over the top of BC and ED. That indicates that we don't really care how long the actual side is, but we know that they are equal to each other. So then we can fill in the rest, but we really want to notate for this video how we're writing every step's reason. In this case, with my diagram, I know that that length is given. So let's fill in the rest. So these proofs are essentially a puzzle. I have to get enough pieces to get to one of my congruency theorems. In this case, I color-coded everything that I had that was given to me. I might have to find more pieces from other math rules, but for now, I'm just puzzling together that I was given a side, a side, a side, so I can actually get to my congruency statement. Now again, like we've been having, we always have to give that reason why I can say that. So now that I've matched my corresponding sides, I notice that AB went red, blue, green. I can go red, blue, green, FDE, and it's what they have for my proof, but I give my reason of side, side, side. Again, the indication that this side led to that, this side led to that, so the arrows are still important in flowcharts, a piece of that puzzle, but these 3 statements and reasons give me my final conclusion that these 2 triangles are congruent. So when you're starting to attack a proof, you always want to have a plan. In this case, always start with your given. So I'm just going to color code again to see what matches up with these corresponding sides. So for example, I could say then PQ is congruent to ST. The reason is they are given. Another piece of information they gave me in this one is that the 2 angles are equal to each other. We could say that angle P is congruent to angle T and not really care that it's 120, or we can write it with the equal sign. Just make sure you have the measure of. So again, I'm plotting this out as if it were a puzzle that I have a side and I have an angle. Now that gives me some options of what my congruency theorem might be. Could be side, angle, side, could be angle, angle, side. So I might have to find some things in the picture that help me find more characteristics. In this case, this is where term 1 material comes into play. I notice that these 2 angles that are crossing at that intersection are vertical angles, which I know are always congruent. So I can write it as angle PRQ is congruent to angle TRS. Now the reason, though, is not given. These are vertical angles. As you'll notice, as we go through these congruency triangles, you're always going to have 3 bubbles. All of the congruency theorems have 3 letters. So in this case, it doesn't matter if you write them as angle, angle, side, or side, angle, side, or whatever the bubbles are, but it does have to get me to my congruency theorem. So I'm going to say triangle PQR. Now if I look to be congruent, PQR started at the red, went blue to green. Started at the red, went blue to green is triangle TSR. The reason being the angle, angle, side congruency theorem. Now we would like to write that as angle, angle, side. The convention is to write that as angle, angle, side, not side, angle, angle. So last piece is this side led to that congruency theorem, this piece led to that congruency theorem, and this piece led to that congruency theorem. Our last example gives us a situation where a certain given may not be outright into our congruency theorem, but it may be giving us more information to find pieces of sides or angles. In this case, they give us that AB is parallel to DC. So I'm going to always write my givens, but in this case, I might start with this bubble to say AB is parallel to CD, and that's my given. But I want to know what that's actually giving me in terms of my triangle. So if I go back to my picture, I might look for some more sides and angles that deal with those parallel lines. If I have this line is parallel with this line, and I have this as my transversal, think about the angles we had in first semester. That's why we had those. In this case, can you see that this angle here is actually congruent to that angle there? So I may want to use three letters like angle BAC is congruent to angle ACD, but it's all about that reason why. This is the idea of flowcharts. Because I know that this bubble goes into here, because the lines are parallel, then I can say alternate interior angles are congruent. So we kind of have this sub bubble here that leads to a next piece of information that just got me an angle in the triangle. Let's see what else they have or gave me. They also gave me these two angles, that angle D is congruent to angle B, which is just a given that they had in that statement there. So then I still have one bubble missing for my congruency, but I notice that I have angle, angle. So I think through my list of theorems, and I do have a couple that have two angles. I have angle, angle, side, and angle, side, angle. The difference between those two is where that side is. In angle, side, angle, the side would be between these two angles, like this side and this side. Now I have markings there, but those are parallel. Just because sides are parallel doesn't mean that they're the same length or that they're equal. So I think about angle, angle, side. That would be dealing with this side, or this side, or this side, and this side. I notice that, oh, there's a pretty obvious one that matches up here. This one here. This is a shared side. So we can actually say that those two sides are congruent. How we'd write that is I would say AC is congruent to AC by the reflexive property. Now, the reflexive property is just saying that it is a shared side. Just like you'd look in the mirror and you'd see the same thing, like your reflection, the reflexive property would say that AC is equal to AC. And now we can get to our congruency statement. So to conclude, I named my first triangle ABC. Again, that's arbitrary. You can pick the first one. You just have to make sure the second one is named appropriately. So I went from the double slash angle to the single and back, so that if I go ABC, that means the second one would have to be CDA, double slash single, and then back to green by the angle, angle, side. I apparently like to do my arrows at the end, but I've seen a lot of mistakes, like then people put like, oh, this has to flow to each of those. Well, no, I didn't know angle D was equal to angle B because the lines are parallel. I didn't know these two side lengths were because the lines are parallel. So I only put it into the one that's an alternate interior. That's the only relationship that it's giving me because the lines are parallel. Now I do know this fed into that angle, that fed into that angle, and that fed into that side, angle, angle, side congruency theorem. So hopefully this helped. We'll practice a bunch in class. But again, some of the format things that you're always going to have three bubbles leading into your congruency statement. You might have some alternate bubbles that are helping you lead into more characteristics, more examples that we know that are eventually getting you to an angle or a side. All right, well, let's get some practice done.